hot water cylinders. At the end of this part of the session, I want you all to be able to visually identify the various systems from diagrams, visually identify various cylinders from diagrams and pictures, and describe the key similarities between all cylinders. There's 5 different types of cylinders we need to know about. A combination unit, this is a cold water storage system built into the cylinder itself, that's why it's called the combination unit. Delivers very low pressure water, which we're going to talk about a bit later on. A single feed indirect cylinder, not something that's fitted anymore. We're going to talk about that and be able to hopefully recognise that system and cylinder by the time we finish this session. Also, double feed indirect coil, double feed indirect cylinder with a coil, and double feed indirect cylinder with an annulus. They're both basically the same thing, they just have a slightly different heat exchanger on the inside. Everything else about those two systems are the same. And a direct cylinder, like we've already talked about really in the last section. There's various reasons why a cylinder could be direct. It could have no heat exchanger and be connected directly to the boiler, so the boiler is a heat source, or it could have immersion heaters, just like we talked about in the last section, so we don't need to look at that again. We're going to look mainly at these other ones now. So firstly, a double feed indirect cylinder. Okay, this is a cylinder that would have two feeds, or a system that would have 2 feeds. Essentially, the primary side, the heating side, would be fed from one source, normally a feed and expansion system if it's an open vented system, and the cylinder would be fed from a storage system. So it's a double feed indirect cylinder, so it has there's 2 feeds, one for the heating side and one for the hot water side. Generally, double feed indirect cylinders are heated with a coil. Here's a picture of a double feed indirect cylinder here with a coil, and you can see just how that works there. We'd have the flow from the boiler flowing in here, going round the coil, heating up the coil, and then the return would go back to the boiler here, primary return, and the coil would heat up the water inside the cylinder indirectly, because it's the heat source is the boiler, and that water from the boiler never comes in contact with the water in the cylinder. So this is a diagram here of a double feed indirect cylinder with coil. You can see, well, you can't see in the corner here, there's a boiler with a flow and coming out of it and return going back to it. This would be described as a primary flow. It would be 22 mil on the main runs. Going to individual radiators, it could drop to a minimum of 8 mil, but on the main runs to the cylinder, if it's gas fired or oil fired, it would be minimum of 22 mil or 28 mil if it's solid fuel fired. And yeah, you can see it all here really. You've got a cold water storage system feeding the cylinder, feeding the expansion system, and filling the heating side. And it's exactly the same for a double feed indirect cylinder with an annulus. The only difference is the heat exchanger inside the cylinder isn't a coil, it's an annulus, and this is a picture of an annulus just here on the left hand side. Essentially it's like a cylinder shape with the middle kind of cut out of it basically, so the water would circulate inside the annulus and then back out the return. Now look briefly at coils. Okay, traditional cylinders have one chunky coil which the primary water flows through, like we talked about a minute or so ago. Though we do have high recovery cylinders which have got multiple coils. You can see with this coil the primary flow would go in and then it splits into several smaller coils, and the purpose of that is to increase the surface area. It increases the surface area of the coil, which means that it increases the heat up time, which was described as in cylinders as the recovery time. of the cylinder, how quickly it reheats after you've pulled all the water out. Sometimes cylinders will have more than one heat source. For example, if you've got a solar thermal panel on the roof, that could heat the water up to a certain amount, but you would need to top up the water, the temperature of the water from time to time using a boiler to make sure that water is safe. We need to sort of heat the water in the cylinder past the pasteurization temperature, which is 60 degrees for at least 1 hour every day. And the best time to do that would probably be sort of in the evening time after the sun's gone in, and that way you're going to get the most sort of heat from the sun. Certainly during the summer months. In the winter, you might want to maybe have the boiler on a little bit more often than that to heat up the water in the cylinder. But yeah, there's twin coil. You can get twin coil cylinders, triple coil, even quad coil. Each extra coil would allow for a different system type to be connected to the cylinder. It's been known for coils to degrade and start to leak over time. We might see this if discoloured water starts to flow from our taps, essentially. That would depend essentially on the height difference between the cold water storage system and the F&E system if it's an open vented heating system in an open vented cylinder. If the F&E was higher than the cold water storage system, that would mean the water pressure in the heating system would be higher, and the discoloured water would flow into the cylinder through the coil. If the cold water storage system is fitted higher than the F&E, then that would mean that actually the water would flow the other way, and we would recognise that there's a leak in the coil by the feed and expansion system overflowing. If the coil is ruptured, gets ruptured at any time, you'd need to replace the cylinder. Now we're going to look at single feed indirect cylinders. In this system type, the primary side, the heating side, is actually filled through the cold water storage system, and every other open vented system type would be fed from a feed and expansion system. And that's the reason why this is called a single feed indirect system, because you have a cold water storage system which would fill up your single feed indirect cylinder through the cold feed, and then inside there, through the heat exchanger, the water would bubble up into the heat exchanger, would then fill up the primary side, the heating side, and once it's full, it would be kept separate. The primary water would be kept separate from the secondary water using an air bubble that would build up in there as you fill the system. Single feed indirect systems have several drawbacks to them. One of those is the fact that the primary side vents into the cylinder, which could mean discoloured water coming from the taps. So if there's ever a fault with the heating system, the heating system overheats, or too many radiators are fitted, and it causes the system water to expand more than it's designed to, then that would vent into the single feed indirect cylinder. Also, these can lose their bubbles over time. The air is absorbed into the water, so then in those circumstances we would also see discoloured water coming from our taps. The only way to recharge the bubble is actually by draining the cylinder down and then refilling it again. So it's obviously less than ideal. So we shouldn't use any inhibitor in the heating side if you have a single feed indirect cylinder installed. That's the reason for that is because inhibitor is a chemical, and if that vents or is discharged into our hot water side, we're left with a health risk which we need to try and avoid. So we shouldn't fit these systems from new anymore. This is a nice picture here which shows or a nice diagram, sorry, that shows a single feed indirect system. So you've got your cold water storage system here with the cold feed, and that cold feed would fill both the secondary side, the hot water side, as well as the primary side, the heating side. Combination cylinders. Briefly mentioned this right at the very start of this PowerPoint. Combination cylinders are called combination cylinders because it's the cold water storage system is combined with the cylinder. These are notorious for having very, very poor pressure, because pressure is generated by the height of the water above the cylinder normally, and in this case it's sitting right on top of it, so it's going to give us poorer pressure. This is an example here. So the combination cylinder connected to an open vented heating system. You can see we've got the cold water storage system here fitted right on top of the cylinder. There is a sort of cold feed pipe which runs down the side of the cylinder, and the vent pipe which runs up the side of the system. So it's all kind of built into one unit. But you need to be very careful with where these are positioned. You should make sure you sort of position them above the highest outlets, because otherwise you wouldn't have any water flowing out at all. And yeah, as you can see, it would have a separate feed and expansion system to fill the heating system. So you've got a cold water storage system built into the cylinder and a feed and expansion system to fill the heating side. So we're going to look at general information about cylinders now. So all of our cylinders that we've looked at will have the following similarities. They will all be graded from 1 to 3. They should all have a sacrificial anode inside them. They should all have appropriate insulation, and that's on the pipework as well as the cylinder itself. And they should all have appropriate temperature controls. And inside all of them, you'll find stratification occurring. And we're going to talk about what each of these to us now. Firstly, cylinder grades. There's 3 grades of cylinder that we need to be aware of. Grade 1 can take up to 25 meters head of pressure. That's 2.5 bar of pressure. Grade 2 can take up to 15 meters head of pressure, which is 1.5 bar of pressure. And a grade 3 cylinder, that's the most commonly fitted cylinder, can take up to 1 bar of pressure or 10 meters head of pressure. When we talk about head of pressure, we're talking about the distance between the water level in the system and the base of the cylinder. In most domestic properties, it's incredibly unlikely we're ever going to have anything close to 10 meters between the water level and the base of the cylinder. So therefore, almost exclusively, we're going to find grade 3 cylinders fitted in most domestic properties if an open vented system has been installed. We also need to know about sacrificial anodes. We need sacrificial anodes. A sacrificial anode is like this thing you can see on the right here, this big rod here. The reason we have sacrificial anodes, or we should use sacrificial anodes inside cylinders, they're pre-built into cylinders in the UK. is because of something called electrolytic corrosion. Electrolytic corrosion happens whenever you've got the similar metals together in water. What happens in electrolytic corrosion is essentially the more stable metal, which should always be described as the cathode in the reaction, essentially takes the electrons from the less stable metal, which would be described as the anode. Interestingly, sort of, almost any metal could be a cathode and almost any metal could be an anode. It all depends on where they are in something called the electromotive series. And the further away metals are in the electromotive series, the larger the reaction, the quicker the cathode would destroy the anode. There's other things that affect the speed of the corrosion as well. Temperature and the acidity or alkalinity of the water can also affect how quickly the reactions take place, and that's why in hot water cylinders, because we're going to have high temperature water in there, we need to make sure that we put something in there to sort of offset that corrosion, which can sort of cause damage to brass fittings. It can cause dezinkification of brass fittings. Brass is a mixture of copper and zinc, and so what can happen is the zinc can be essentially leached out of the brass fittings that are connected to a copper cylinder if the sacrificial anode isn't correctly installed. When a sacrificial anode is installed, because in electrolytic corrosion, the cathode will always destroy the most anodic material first, the one that's furthest away from it in the electromotive series. Therefore, it will always destroy the sacrificial anode before it would then start attacking the zinc. That's because magnesium is further down the electromotive series than zinc. Energy efficiency and insulation. All new cylinders have to have appropriate levels of insulation, and most cylinders these days will come pre-lagged or pre-insulated. Though you do still sometimes get some which need an insulating jacket. The requirement for insulation is set out in Building Regulations Part L, which covers conservation of fuel and power. It's got a supporting document which has got a lot of very relevant information to both hot water and heating systems in it, called the Building Services Compliance Guide. This gives us information about temperature control, insulation, heating, and a lot of other things about heating and hot water systems, like particularly around controls. So there's lots of different benefits to insulation. It helps prevent heat loss, and it also reduces the risk of freezing. And interestingly, it can also prevent heat gain in cold water pipes. If you have hot and cold water pipes running close together, the hot pipe can actually start to heat up the cold pipe, which can cause risk of Legionella. So we want to try and avoid that just as much as we want to try and prevent the hot pipe from cooling. We've talked briefly about sort of what happens when hot water cools in long dead legs, and insulation can help prevent that. It can help limit what we call undue consumption of water, wastage of water essentially. Worth noting, all primary pipe work, as far as possible, should be insulated, and the hot water system pipe work, if it's got a return on it, should be insulated along its entire length as far as practicably possible. If it doesn't have a return, then the maximum uninsulated pipe lengths are 12 metres for 15 and 22 mil pipe. But it's also worth noting all of the pipe work into and out of the cylinder should be insulated for at least 1 metre. And like I just mentioned, if the pipes are left uninsulated, then you should try and avoid the hot and cold pipes touching each other, like shown in the picture, because that can cause heat gain. And ideally, what we should do is fit these pipes running separately, with the cold running underneath, the hot running on top, so the heat from the hot pipe doesn't rise up and cause heat gain in the cold. Limescale, we're going to very briefly look at this. Limescale can be a big issue in cylinders. As the water's heated, it starts to precipitate out. It's particularly an issue with what we'd describe as temporary hard water, water that contains calcium carbonate. And as that heats up, the limescale will start to come out of the water, and it can block up pipes, and it can block up the heat exchanger, which can actually reduce the efficiency of the heat exchanger. It can also block up pipes and showers, which again causes issues with efficiency with the showers themselves. You can reduce the likelihood or incidence of limescale by using a water conditioner, the city girls would call it. Most people call it a water softener. And you can see a nice picture here of a base exchange water softener that you'd fill with salt every so often, and they cause reactions which make the salt react with plastic beads which are in there, and then as the hard water flows over the plastic beads after they've been sort of charged with the salt water, I suppose, then the water comes out the other side softened as a chemical reaction that happens on the plastic beads. You can also use scale reducers. You'd see something like this most likely on the inlet, cold inlet to a combi boiler. Temperature controls. Temperature to cylinder would be controlled by a cylinder stat. It should be fitted a third of the way up from the base of the cylinder. Worth noting, if you do have a pre-lagged cylinder, you should cut the insulation off where the cylinder is going to be fitted, because that way it can actually sense the temperature of the water inside the cylinder. It should be set at a minimum of 60 degrees C. That's what we describe as pasteurization temperature. Legionella bacteria would die off within seconds at that sort of temperature, so that's the minimum temperature it should be set at, and it should be set at a maximum of 65 degrees to reduce the sort of risk from scale in hard water areas. Also helps keep the system a little bit more efficient. And finally, we're going to look at stratification. Essentially, hot water rises, or it'd probably be better to describe it as cold water falls. So inside cylinders, you're going to find layers of temperature. As you go up the cylinder, the water is going to get hotter. So you're going to get the hottest water at the very top. And that's why we take our vent and distribution pipe off the top. It's also the reason why we put the cold feed at the bottom. We put the coldest water, cold water, in at the coldest point, which can then be heated, and as it's heated, it will sort of start rising up towards the top. And that's what stratification is. It's different layers of temperature. It's also the reason why we actually should fit the cylinder stat 1/3 of the way up from the bottom. The reason for that is so the vast majority, at least 2/3 of the cylinder, is heated up past that sort of safe temperature, the pasteurization temperature of 60 degrees C, which is the minimum temperature that we should have that cylinder stat set at. Okay. And now it is time for your task.